Project: predict an apartment's rent from its size. One input number in, one prediction out. We'll generate a tiny dataset, visualize it, fit a linear regression, evaluate with real metrics, then use it to predict rent for a new apartment. No magic words. Every step has an explicit input and output. Step 1. Create data with a known rule plus noise. Input: a list of square foot values. Output: rents generated by rent equals 2.1 square foot plus 250 plus random wiggle, because real life isn't perfectly linear. We'll keep it small enough to see every dot. Step 2. Visualize. Input X and Y. Output: a scatter plot. Your eye is already doing regression. You're mentally placing a line that balances the points. The key is, we're not hunting for a perfect fit. We're finding the trend that best predicts unseen apartments. Step 3. Define the model and the learning objective. Model: RU X plus B. Input: a specific apartment size X. Output: predicted rent. Learning means choosing W and B to minimize average squared error. L equals 1n and it's Y cuadrado. Squaring punishes big misses. Step 4. Learn W and B with gradient descent. We compute how the loss changes if W or B nudges slightly. The gradients are ddw equals 2 minus yn and db equals 2 the n. Then update w minus hu dl the b. Step 5. Watch learning happen. Input: the recorded losses over time. Output: a curve that should drop quickly then level off. If it explodes, AVA is too big. If it barely moves, AVA is too small. This is the simplest debugging tool in machine learning. Plot the loss. Step 6. Overlay the learned line on the data. Input: X, Y, and learn WB. Output: a picture answering, did the line capture the trend? You should see residuals, vertical gaps, because noise exists. The goal isn't zero error. It's a useful predictor for new X values. Step 7. Evaluation with a real trained test split. Input: the dataset. Output: 2 losses, train MSE and test MSE. If test error is much worse, the model is overfitting. For a line on one feature, that's unlikely, but the habit matters. Evaluation means measure on data the model never saw. Step 8. Make an actual prediction. Input: a new apartment size, say 875 square feet. Output: a rent number. Then sanity check. Is it between nearby points? ML isn't only about computing, it's about reasoning. If the model predicts $10,000, you don't celebrate, you investigate. Full code, end to end. If you run this script, the outputs are generated arrays, a scatter plot, a decreasing loss curve, a fitted line plot, train test MSE, and finally one prediction for a new apartment. Once this works, swap the synthetic data for a CSV. Same pipeline, same debugging tools, real stakes.